Okay, so we're finished with chemistry and we're moving on to physics. It's not like one's easier than the other necessarily. It's just that I need you to understand physics has a weird way of thinking and a weird way of explaining things. And you should be able to tell that by the first question that we're going to go over. Okay? They talk about ordinary things. Most of the time, physics is about things that we really can't see, but they just explain it in the weirdest way. So that's the part that I need you to kind of grasp and understand and make sure you ask questions on. So our first question that we're going to go over is, how can we tell that an object is in motion? How do we know that something is moving? How do you know that I'm moving that right there? You can see it, okay? What allows you to be able to, what are you seeing, though, that allows you to know it's in motion? Well, how do you know that I'm in motion? Okay, but how do you know that I'm walking? No. But what are you seeing that shows that I'm in motion?
Your legs. You think? You move from one place to another.
That is exactly why I start this way. Because it seems so like, what the heck, lady, we see you. Right? That's how they think. It's just weird. It's weird. Why would we even, what does that even mean? You know, like, what the heck are we talking about? Do you know how they would make, like in an old movie, like if somebody was driving a car, do you know how they would make that be in the movie? How would they do that?
Make the background feel it.
Tell me again.
Make the background move.
Make the backgrounds move.
It's wrong.
No, you're right. Was the car moving?
No.
So how do you know that I'm in motion?
Because the background is staying still.
Exactly.
Oh, we get bar bucks for it, man.
So, okay, so now I want you to kind of think about that outside of this room and in your everyday, like what you do every day. When you're in a car, how do you know you're moving? Because the tree doesn't. And it sounds so like, what? But that's how motion is explained. That's how, think about when you're in the car and there's another car on the side of you, and they're going like the exact same direction and everything as you and the same speed. Doesn't it like, you're thinking,
That's only when like it's an 18-wheeler. It's not a regular car. It's just like when the 18-wheeler is making it. But I know what you're talking about.
if this thing right here moved as I moved, would you know that I was in motion?
No.
That's the point.
Oh.
That's where motion, okay, that's where motion comes from, period.
So that's how they explain it. It'd be like, because the background.
That's how we know that something is moving.
Because the background's not moving?
Yes.
So that's whenever you're in a car. What if you're looking out the window and you're trying to like stare at a tree and you can't?
Yeah,
I'm trying to make my eyes think.
exactly, and doesn't it seem like the tree's kind of like going backward, but it's not what it is.
Like
Okay.
my eyes like.
And motion is relative. It all depends on what's around it. Okay, but the answer to our first question is because everything around it is not moving. So where my motion actually comes from is an object's change in position. You have to change position. An object's change in position over time when compared to a reference point. So what we've been talking about the other objects, they were the reference point. You're like, if something's moving through the sky, you might use the clouds. The reference point just depends on what's in the view. Okay? Usually the reference point is the thing that what? Doesn't move. So we have two quantities that go with this. What's a quantity? An amount of something. Yes, so this is all going to deal with numbers right here. Two quantities. The first one is called scalar. Say it.
Scalar.
A scalar quantity. This is described by number alone. Only numbers. The second quantity is called vector. Y'all remember on Despicable Me, the guy named Vector? What did he say about his name? He did say V as in vector.
Oh, that guy.
He does.
I'm always saying.
He says vector, direction, and magnitude. Y'all remember that? Okay. What vector actually means is it's a magnitude and a direction. What does magnitude mean?
Well,
How much? An amount.
wait, just so if I remember correctly, the vector is like the orange and white guy, but not
Yeah.
orange and white guy, but he's wearing the orange and white clothes.
Something like that, yeah.
The one that had that sky thing. Yeah.
Yeah, it was on the first one. So, a number with a direction is a vector. Only a number is scalar. So, 5 meters. Leah, is 5 meters a scalar or a vector? I was asking her. Kaylee, 5 miles north. What would it be? So it is everybody, when it has a direction. 30 meters per second east, vector. 20 degrees Celsius, scalar. There's no direction with that. 75 pounds, scalar. Who doesn't understand? Say it again. Say it again. There's no direction with it.
Oh, magnitude and direction.
Mm-hmm. Yep. It has to be both. Okay? So, vector questions are going to be worth how many points? 3. 3. A number, a unit, and a direction. Oh. Everybody understand? Okay. So, we have drawings to represent a vector, and they're called vector diagrams. Vector diagrams. They show a vector quantity by using an arrow drawn to scale in a specific direction. What is to scale? What's that? What's scale mean? To scale. It's drawn to scale. Okay, let's say we were drawing something that was 5 meters. How am I going to put that on my paper?
If you don't want to say it's 5 meters.
Okay, that's a good way to put it. So I would use the scale. What I would say is maybe 1 centimeter is equal to 1 meter. So when I draw 5 centimeters, that would be my 5 meters. Make sense? Okay, awesome. Oh, yeah, okay. That part, the scale is in the key. Like it's on the bottom of the picture somewhere. She said it would be like a key. You know, like on a map or something. It would be down there somewhere. It's in that key. That's a good way to put it though. Okay, so this right here, that's a picture of a vector. That's a vector right there. It's an arrow. No, it's just that it's an arrow and it's in a certain direction. Yes. Okay. There's 2 parts on a vector. The head and the tail. Okay, the other thing I mean by scale, like if I had one that's smaller than the other, I would have to draw it, like if it was half the size, then it would have to be drawn as half the size. Does that make sense? Like 15 centimeters compared to 30 centimeters. So this would be the 15 centimeters, this would be the 30 centimeters. And I tilted them wrong. They should have been at the same tilt. Can you tell what I'm saying? Like he's like straighter than him. Well, girlfriend, I don't know what to tell you. Okay, the other thing I need to talk about now. They have a weird way of saying direction. So these 2 would be east of north. What the what? What the what?
East of north.
Okay, where's north? Directly up. And this one is to the right.
Oh, so up just went a little bit to the north. They try to come big.
I drew that too big, but there's my vector. What did I draw right there? What was that little curve line? An angle. So maybe he would be like 30 degrees west of north. Make sense? Oh, okay, you want me to north, south, east, west. Yeah, you're gonna deal with that a lot. Okay? You gotta know your directions. Okay. So some different measurements we can take or talk about would be distance and displacement. It cut out your little d. So that's distance. That one's displacement. Distance. How much ground you have covered. So distance is all of the steps I take, everything I travel, all of it. So if I'm going from A to B, distance is all of it that I walk. I go here, go there, go here, go around, go there. Distance, all of it. Displacement is how far out of place an object is. How far out of place. So I started at point A, I ended at point B. How far out of place am I? Nope. Okay. But I could walk all kind of different ways. Up, back, around, all kind of stuff. And then where I end is how far out of place I am. So let's say I did a loop in there and came back and then went over here and then I stopped here. I started here, I stopped there, the shortest distance between 2 points, straight line. How far am I from where I begin? That's what displacement means. So you can also write how far from where you start. Which one do you think is scalar and which one do you think is vector? Which one would be number alone? Distance. And which one do you think would deal with the direction? Displacement, so that is vector. Okay? Nobody has a question so far?
No. So is this the same thing as a different name?
No, it's not the same thing.
No, basically pretty much almost technically. So
No, Then you don't get it.
So why would you put the scalar and vector right there if they have nothing to do with each other? That's going to do with each other. I think it's
Oh, that vector goes with displacement and scalar goes with... Yeah, those have something to do with each other. I thought you were trying to say distance and displacement. Okay, yes, you're right. Everybody's ready to calculate?
Yeah.
Now we're going to figure out how to actually calculate it. Okay? You start at position X. You're going to travel 4 meters east, 2 meters south, 4 meters west, and 2 meters north. What would be your distance and what would be your displacement? Distance is what? 12 what? You have to have a unit. Every distance question is worth 2 points. East, 2 south, 4 west, 2 north. What is your displacement?
So 12 meters. 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 12 meters.
Okay, well, can you tell me what the definition for displacement is again?
How far place are you?
How far out of place it is?
0.
You're back to where you began. How far are you from where you started? You're back to where you started. So you don't have a displacement. It's 0 meters. No.
Okay, this is like it. That displacement is that.
Okay, then you need to go back in your brain to the original definition. Distance is going to be all of your steps, all of your stuff you traveled. Displacement is going to be how far are you from where you began. Okay? Okay. Little Timmy. Here he is. Little Timmy is walking to his friend Billy's house at point B. They will then walk to the store at point C. On the way back to Billy's, they decide to stop and see another friend at point D. What is the distance that Timmy walked? And what is his displacement? Everybody calculate it. I didn't hear you, I'm sorry. His distance is all the ground he's covered. Who got that right? Okay. What about everybody else? What's going on? Okay. How much is it from here to Billy's house? 180. How much is it from Billy's house to the store? 140. How much is it from the store to see Danny? 100. Add them up. Okay? What is Timmy's displacement? It's a vector. I need all the information. 140 meters east. Who's lost? Is this where Timmy started? Where did he finish? When we're to the right, we're going to assume automatically it's east. Unless they tell us different. They could tell you different in a situation, but we're going to automatically say that's east. If we're to the left of where we were, it is west. Okay? Okay. Everybody calculate Billy. Morgan, do you know Billy's distance? No? Yeah, he started at B. He started over here. He goes to C. And then he goes to D. What's his distance? 240 meters. What's his displacement? 40 meters west. Who doesn't understand? Yes, you got it? Everybody's got it. Yes, ma'am.
How is the left? Let's go to the left. Oh, okay.
Everybody's cool. What'd you say? No. Okay. I drew these right here underneath so that I couldn't put it on the line. Yeah, I know. Everybody said that today. So I put it underneath so that you could see he turns and goes this way and then goes that way. He's walking linear. So everything we've done so far is called one-dimensional motion. Now we need to do two-dimensional motion. This is just one-dimensional motion. It's just either going to be like this or like this. One or the other, up and down or left and right. That's one dimension. So now I'm going to combine two. A squirrel travels 3 meters east toward a bench, then he turns north and runs 4 meters towards a tree. 3 meters east toward a tree. Toward a bench. Sorry. 3 meters east toward a bench. Okay, now he went 4 meters north toward the tree. Okay, so I need to put their vectors together. This is vector addition, okay? The tail of the second one goes on the head of the first one. So, here's his head, right? Mm-hmm. The tail is going to go like that. 4 meters. Does that make sense? Mm-hmm. I just need to put their head and tail together. So his head goes to his tail.
So you going to add those?
Okay, so I add those to get his distance. So what's his distance? His displacement is how far he is from where he started. So he started here and he ended, didn't he?
Yeah.
Well, guess what? Oops, I can't draw a straight line. That line is his displacement.
Oh.
What does that look like? How do I find out that side? Pythagorean theorem. Oh, yeah. So A squared plus B squared equals C squared.
We gotta do this again. I thought words never I like it, but then it just gets too much. Oh my God.
What's that equal? 25 equals C squared. And how do I get rid of that little square? Take the square root of both sides. So C equals what? 5. So guess what? His displacement is 5 meters. And he is north of east. Oh, yes. Oh, yes. 5 meters north of east. So you only do it like that when it's in 2 dimensions. When they say like he went from one direction to a different, like this didn't go east to west, it went east to north.
Oh.
Into a different quadrant, basically. Okay? Not for all of them. Nope. Not for all of them at all.